So this won't be about Symfony much, or about PHP really. It's more about hosting, which I guess is still relevant to everyone. Yeah, let's get started. So just a little quick intro about myself. I've been like doing internety things for, I don't know, I stopped counting at 10 years just because it's too long ago, I can't remember anymore. But I've been doing this for a while. The last 7 and some years I've been leading Composer as well and Packagist. So there I've had to do a lot of like hosting things as well. Which kind of brought me to this talk. And for the last 4 years, I've also been doing development and lately operations at teamup.com. And I noticed like all of these projects kind of have this need of like a global audience, and I've been thinking about this problem of like how to host a website across the whole planet. For many years now, it's been obsessing me. So as I've been doing a lot of that lately, I thought it'd be interesting to share this with people because I haven't found a lot of resources about it. So first of all, the question I think is really why would you want to do that? So why host across multiple regions as opposed to have a single data center? So I think really the first point you need to have, like the first problem you need to have is having users that are in more than one location. If if you have like a German website with only German users, you probably don't want to host it like in other regions than Germany. It just doesn't make sense. In the US, you could argue that between East and West Coast, it's kind of a big country, so I think there it's arguable in terms of latency and so on, but I think once you have really users across the whole planet, latency just becomes a problem. Like, I know we saw this on Teamup that we have like, I think like a full page load in Europe back when we were only hosted in Europe was about like 200-300 milliseconds. And for users in Australia, we had like over a second. So, you start seeing like it just adds up. Like with every round trip being a little bit slower, it adds up to quite a bit of delay. On top of that, you have also like temporary network failures, I would say, which tend to be larger the longer distances you go. So we usually had issues with, we have quite a lot of users in Australia, and it so happens that, between Australia and Switzerland, there was quite a long way, many hops. And if there's anything going wrong in between, they can't access the website. So that's the first thing. The other critical thing for, again, it depends on the projects, but for any kind of serious company, you want to have redundancy because, if let's say, Amazon, Google Cloud, all of this, they're pretty good. Like, usually it runs smoothly, but it definitely has happened in the past that an entire region is down. Like, AWS, I don't know how familiar you're with it, but there's this concept of availability zones, which say that, they're like unique data centers. Even in one region, you have multiple availability zones. And they say these should be completely independent and they cannot fail together. Well, usually they don't, but it definitely happened. So if you put everything in one region, sure, you can have redundancy in terms of servers and whatnot, but you still might have like a critical failure at some point. So having multiple regions really helps in that case. Then lastly, I see like lots of people using CDNs for web assets and images and whatnot. So I'm wondering like why only that and not like your API or just the main application servers? Like, just why not? So yeah, why not doing it? I think there are a few reasons. I mean, I don't know. Is anyone actually hosting like something in more than one region, like actively? Okay, that's like 4 people. So that's not a lot, I guess. So I don't know why the others don't do it. I mean, I came up with a few reasons why I didn't do it until now. If you have more, I'm happy to discuss this later. And clearly, I think the major challenge comes with the database, just because like everything else is fairly easy to replicate. So that's the protests are getting louder. Anyway. So you have like some databases which help in that regard, I think. Like the NoSQL side of things, like MongoDB and others, I think they're a bit more ready to be like distributed across regions. Like traditional SQL databases were not, they just weren't built from the ground up to do this. So there are solutions, but it tends to be a bit trickier. I think like if you have a chance to, using Google Spanner is probably the most mature solution I've seen, but I also haven't really used it, so it comes with, on paper it looks like the most mature solution. To do like relational database with multiple regions, multiple masters, and so on. Aurora from AWS has announced, I think last year, about a year ago, that they were gonna do multi-master setups. I think it's in beta now. I haven't tried it. Like it's coming slowly, but so I think it's not there yet in terms of maturity. But the upside with Aurora is that it's like completely emulating MySQL or Postgres. So if you're using one of these, you can like switch to that much easier than like Spanner has a kind of SQL interface, but it's still a bit its own thing, and I don't think it's a drop-in replacement by any means. Then we have like DynamoDB and things like that, which are more just document stores, which it's kind of a MongoDB replacement, I guess, in that sense. It's not really relational. Then we can argue about MongoDB, whether it's relational enough or not. I'm not gonna get into that debate. I'll let you make a decision. So another issue really is like cloud providers, they claim to solve all these things magically, but when you look at the fine details, it actually, like, there usually are some cases where you get stuck. And like a few examples that I've encountered were with Redis, in the sense that AWS just like does not replicate Redis across regions. You can have many replicas in one region, but if you want to have like a read replica somewhere else, not possible. So I don't know why. Maybe it's coming one day, but right now that's kind of a blocker for some use cases. Another issue that was, thankfully that was fixed last year, was that you couldn't really communicate between VPCs. So VPCs are like these sort of private networks that you can build up to have like all your machines, like all your VMs and database instances and whatnot, like talk to each other within this private network that's not exposed to the internet at all. So that's really good in terms of security, because you're not exposing any ports to the internet. But that means if you have more than one region and they cannot talk to each other, well, that's also blocking some things. So this is not available, so it's not a problem anymore, but it has caused issues in the past. Then lastly, I think there's an issue of awareness in that most of the developers, they're like sitting at some super good connection and everything runs well. And like they're usually close-ish to their data center, and so they don't suffer from this latency. I mean, for sure, if you have like remote people and so on, or more global development teams, this is not necessarily true. But I think in a lot of cases, teams are fairly centralized, and so maybe like if you're on holidays on the other side of the world, like check out your website and see how painful it is. It's usually an interesting exercise. So now I have 3 cases I'd like to go through with like different kind of levels of multi-regionality or and complexity as well. So the first one is packages.org. So the goals we had here, like first of all, is high reliability, just because we have the entire like PHP community that's hitting it all day, and if it's not there, we get complaints like really quickly. Related to that, I kind of want it to be simple because like it's a small team in that it's usually mostly me. So like we can't afford like super complex setups, and it just needs to run and run well, and like it needs to be like as simple as possible so that you don't have too many moving parts that can break. It also needs to be absolutely global because like we really have like users everywhere. Like I think on the website already is like looking at the Google Analytics. There are people from every country on the planet that are hitting it. So it needs to be all over the place. And it also kind of needs to be low cost, like historically, because I was paying out of pocket. Now we have private packages that's funding it, which is nice, but it's still good to keep it somewhat a manageable expense. So what did we come up with? We built around CDN, kind of. So what we have is we have a set of mirrors, which are really just simple servers, and they're pulling from one primary machine. So the way this works really in the back is you have these JSON files which are like contain the metadata for all the packages. So these files need to be updated like really quickly, because when you push a commit to an open source package, we update the metadata and we need to dump that to the file system. So we have this updated JSON file, and this needs to happen like as fast as possible, because usually when people like commit something or push a new tag, like they want to update another project that depends on it or something like it. You can't have like super long delays on this, and that kind of like made using other CDNs a bit difficult, because controlling the invalidation there is quite tricky. So also I mentioned there like that they're pulling from the primary server when it's up, which doesn't mean it's down all the time, but the point there is really to say if it's down, or if like the link between the servers is down, which again, like networks are fairly unreliable. You don't want like the mirror to become corrupt or like start losing updates after it's back up or anything. So if it can't connect, it's just nothing happens. It's stale, but that's about it. So it's a good property in terms of like simplicity and lack of maintenance. Thanks to the way it works as well, like we get really, usually within seconds, we're up to date on all the mirrors. So invalidation is not really an issue. Then to distribute the traffic, we use this like Route 53, which is the DNS service of AWS. So that like distributes people according to regions, or like to latency to some servers, and then we have some kind of round robin between servers in one region. Then on top of that, we have a bunch of health checks which are like just constantly checking that the mirrors are up. If one of them is down, like this happened a few weeks ago. I don't know, it's like one of these cloud instances, you know, it's just like something happened and it died, because that's what you get with the cloud. So it just vanished overnight, and like I got alerted that the machine was not responding anymore, but like on the website, like on the access for the users, this didn't really affect anyone. Or like probably there are a few minutes, there's a little window there where the DNS needs to update and so on. So you might lose a bit of traffic, but like usually if people retry, they'll just be back on track within a few minutes. So it's kind of self-healing in that sense, which is also good. And finally, it's really easy to set up new nodes, like because it's just a set of like static files that are hosted there. They just pull them like within minutes to a new mirror is up to speed and it can serve traffic. So it's very low maintenance, which is great. Okay, I'll just go quickly to downsides. One problem there clearly is that it's only the repository. So it's only the package metadata that we're mirroring. The website is still in one single region. So this is acceptable to me in this case, just because like manpower and whatnot are like not allowing us to go further really. But yeah, it's a trade-off, right? Like you have to see what you can do. Then yeah, it's quite a party out there. So what we have, like one issue we had actually early on was this, because this stuff I deployed it like to really many regions back in June, I think. So we did quite a long time. We had only a region in Europe, and then we added one in Canada a few years back. And then I kind of spread all of this in June, like a few regions in Europe, and we kept Canada, and we added one in Singapore as well, because Asia was really not well deserved before. So anyway, after doing all this, one issue I realized is that with the DNS Roundrobin, like someone can hit like 2 consecutive requests can actually resolve to different IPs in the same region. And if like one of the mirrors is up to speed, but the other one is still catching up, you can actually hit a file that's not been like mirrored yet, so it's not there. And it happens not so often, but it just sucked because like randomly you had some failures like that. And I really didn't understand, like for a long time people were reporting this and I was like, hey, I don't know, like the file is there. And because obviously, 2 seconds later you go check and it's there. So, so like once I got it, I was like, okay, that's a nasty one. But it's fairly easy to fix. You can just, like we have a rule in Nginx so that if the file is not there locally, it just goes and tries on the primary server. So it just proxies it instead of serving it from the local file system. If you still get a 404, then that's it. But this works fairly well, I think. So that's it for the packages.org case. If you have any questions about this, I think we can maybe look at that now, just so it's still fresh, but otherwise at the end is also okay. Nope. All right. So the next one is private packages. So that's it. It's a similar service, right? So it's kind of like the .org one, but for private code and private packages you want to host, and for businesses and so on. So we have kind of different requirements there, even though technically what it does is fairly similar. There definitely security is much more important because we're hosting private code, so leaking that is not good. Like on the .org one, it's all open source stuff anyway. Like not much bad things can happen. It's also fairly global, although a little bit less so. I mean, I think our customers are mostly North America and Europe, so we can it's a bit of a different trade-off there. But I think ideally we also want to be everywhere. Speed is also quite essential there because that's part of the value proposition. So we want it to be really responsive, like for all the users, it should be close to them. And again, like reliability, because we have paying customers, we really want to be up. Because it's not just about people complaining on Twitter, it's like people paying us complaining, so it's a bit more important. So the solution is like similar in that it's sort of a CDN, but how it's implemented is actually completely different. So in this case, what we have is every mirror has like a replica of the database. So that's like done through AWS. That's easy. You just say, okay, I want a read replica in this other region. They do it for you. Easy. Then we have like Redis and S3. So the difference there as well is that we serve from the repository. We serve the zip files as well as the JSON metadata. So there's a bit more data we need to store. So that's in S3, and so that we have in every region. We have like some cache stuff in Redis, and then the S3 zip data. And then, like this comes to the problem of not having the ability to talk between regions back then, because this was built like before the cross-region VPC peering that was announced last year. So we didn't want to open like any database ports to the internet or something to talk between the regions. So we just thought to play it safe, we'd rather just have an API endpoint. And then we go over the open internet, sure, but at least it's like over HTTPS and like signed requests and this and that. Like we have enough layers there that we feel it's a lot safer than just opening up like Postgres and hoping that the Postgres authentication system doesn't have a bug in it, because wasn't too comfortable with that because it happened in the past that things went bad. So a few challenges there. The Redis replication. So what we do is we cache some like credential related stuff in Redis, because that's fairly heavy to compute. The issue there is that like, if you remove a user, let's say from your organization, you don't want them to have access to the code anymore, right? This should be applied immediately. And like if you have some cache that is stale, it's not good. So if we could just replicate the cache across regions, that would be easy, because you delete it like from the cache in one region, it goes and deletes it everywhere, done. In this case, as we have a cache in every region that's independent, we need to make sure that we're actually deleting everywhere. But the only way we really have of talking between regions safely is through the database replication. So that's kind of what we did, is just like pushing a list of Redis keys into the database that has like Redis keys that have to be cleared. And so every region is like reading that list and just deleting locally. The good thing there is really like, if network drops for a period of time or anything happens, you will anyway, like, the replication will catch up eventually, and then you will process this. So it's reliable, like it, While the other aspect I kind of talked about is there was no way to talk between the regions, so we had to build this API layer on top, which is not too bad. I mean, it's not a lot of code, because in this case we have only a few things we wanted to do from the replicas to the master, but in some cases, this could actually be a real issue. So what are the downsides here? Again, it's only the repository. We don't have the full copy of the website everywhere. What this means really is that the updates, also like the package updates and whatnot, are only handled in the primary region. If that goes down, massive failure at AWS, that just means we are not updating packages anymore. It's not great for sure, but at least we have a fallback region for installing packages and so on. So, the core use case, I would say, is still up and running. Okay. So the last one is Steamup.com. So that's it's like, because I guess you're probably not familiar with it. It's an online calendar web application. So it's like single page app with JavaScript and lots of API calls. Yeah, so that's the bottom line. So the goals there, again, really global audience. So we did want to have better latency for people that were far away. I mean, before we were only hosted in Switzerland, which, I mean, it's okay for Europe. It's decent for the US, but then further than that was kind of. We also want really high reliability for reads. At least to accessing data is super important, because we have a lot of businesses that they built up their entire business around the calendar somehow. Really for a lot of companies, small businesses, they just it's their entire schedule, entire task list. If they don't have their calendar data, they just don't know what to do. They're literally the whole company shuts down. Which before, when we had fairly regular outages with a single region hosting, this was not good. We had weekly outages. It wasn't at the end, before we migrated, it was really not in a good spot anymore. It also needs to be somewhat low maintenance, because it's a small dev team, and we don't have the budget right now to hire 10 people to do reliability. Speaking of reliability, so yeah, it just has to be somewhat self-managing, which I think it is right now. I mean, we deployed this in February this year, and yeah, I think we haven't had a single outage of the website. We had some background workers dying at some point, but that's not affecting too much. And yeah, I think it's been going really well, and not too many panics anymore. So at first, what we built was so using Terraform, AWS, we built up this whole system. Terraform, in case you're not familiar, is this it's kind of like Puppet and Ansible and all that, but for managing the infrastructure really. So it lets you configure all the AWS services that you wanna have, and link them and so on. So you can have a recipe for that, and that's good because especially for the replicas, now we can just copy paste 10 lines, change the region we want, and deploy a new region. So that's quite nice. So the primary region has everything running in it, including the workers. In the replicas, we have everything, website and database and so on, but no workers. So workers are only in one region. That's a little trade-off we did, just because it makes more sense to like to avoid like a lot of latency between data centers and like shuffle data around for background jobs. It doesn't really bring much. If you're using multiple availability zones and like, you know, things are not really, really bad at AWS, it should be fine. So the sessions though, they're like completely local. So in every region, we have a known set of sessions, again, because Redis is not replicating across regions, but also because this is not really an issue. Like, I mean, people don't usually move fast enough that they're gonna change region during a, you know, a browsing session. Like, and
if they do, they relog in.
Yeah, that's the thing. Like, worst case, you lost their session. They have a, like, either they have to relog in or the remember me cookie will do it, or like, yeah, it's not really an issue. So for all the reads, that's like a great setup. It's super easy. You just have the local database copy, you read from it, you render the page or the API request. Super simple, that works great. Problem is with the writes, well, you need to talk to the master server, right? So in this case, we had the VPC peering available because they announced this late last year. So I thought, awesome, finally AWS can do this. Like, let's go nuts with this. It's gonna be great. So we just like have a request coming in. We connect to the primary server, like primary database server, do the thing, return response. It's like nothing can go wrong, right? Except that was kind of the result in terms of like response time. That was just like really, really slow. And I mean, I felt super stupid when I realized what was going on. I mean, it's kind of obvious in hindsight, like, but just didn't think of it somehow. That obviously we make, you know, a few database queries, a few Redis queries, and this and that, and all of these have like this 60 to 100 millisecond latency between the replica and the primary server. So, you know, you do like 10 SQL requests, SQL queries, that's like a second of latency for your response. Not so good, right? Especially when, if you make the user go directly to the primary region, maybe they get like 150, 200 millisecond delay because they do like one round trip and then they're done. But you're like serving them very locally, which is great, but then like you do 10 round trips here, and then like it was actually way slower with the replicas than without. So I was kind of bummed out there because I thought like, okay, that was a lot of time spent for nothing. But you know, I didn't let that like make me stop or anything. So I tried to use Proxy SQL because I thought, okay, like every time we have to open a new connection to the database, and that's already a few round trips actually, just opening the connection. If the connection is using SSL, like you have like 2 or 3 round trips, like already this was just like killing us. So with Proxy SQL, you have a local proxy, and it keeps the connection open. So you're just connecting locally to Proxy SQL, which happens like instantly, and then you're reusing one of these open connections. So that helped for sure, but we still had the latency on every query that we were doing, and that was still not working well. So we just tweaked things a little bit and decided to like proxy the entire request internally. So when a write request comes in, we just say, okay, like if it's a post, put, delete, anything like that, we just proxy it completely to the primary region. So that it gets handled in one go, and we have like, you know, the user connects to us locally still, so they get like a fast connection time and so on. And we have like decent connection as well between data centers. So this sounded great. It helped a bit, like definitely. It came with a few requirements though. The session data, well, you know, again, like something you don't necessarily think of, but then you start like proxying requests and you're like, why am I logged out all the time? And obviously, yeah, the sessions being local in every region, well, you don't have them anymore. Now, how do you proxy the session nicely? It's not that easy. So, like either you build up some special endpoint for proxying requests and then do like some stuff that I didn't feel very comfortable with doing. Or what I came up with was to just like pack the whole session data into a header and ship that off with the proxied request. This works reasonably well. There's a catch which I'll get back to, but it works well now. We also forward the client IP, obviously. I mean, that's nothing too special. So we go over the VPC peering so that we don't leave the private internal network even between regions. We also have HTTPS between the servers, so this should be all like secure in transit because you're also like sending off, you know, session tokens, stuff like that. Like if security definitely gets a bit critical there. Like to have added security, we also signed those requests, so to make sure that they came from our server and not like anyone that figures this out can just like, you know, send us a request with a user ID in the session data that like matches anyone and do things like that. It's unlikely that someone would figure this out like without the info of the code, but like this is definitely safer than trusting your black box. Then finally, like if somehow this proxying fails, which can happen for various reasons, we just like process it as we did before, which is like connecting to the primary server, like the primary database, and like computing the request locally in the replica region. So we just have a fallback there, which is quite handy. So that's the results. Like it's much faster, but it's still a turtle. So, I mean, what happened really is, I mean, it was good. Like it was consistently, like the speed was consistent because we only do one round trip internally. But there was like, it was still slower than me hitting the primary server directly from my browser. And I was like, that just annoys me because like it defeats the whole purpose. Apart from having the additional like reliability of having multiple regions, it's still like it's not faster. So not so good. So the issue I found out eventually again after like a lot of head scratching is that, you know, internally we connect to the primary region. And that means opening up an HTTPS connection, which has, again, a few round trips. While on the browser side, while you open that connection once, but then when you do another API call or a page refresh or whatever, the connection is already open. So you don't have to pay that price multiple times. You just pay it once, and then the next requests are like really fast. So the solution there is not that hard. It took a bit of tweaking. Is to go through a local Nginx proxy. So that's kind of the similar thing to Proxy SQL. So we use a reverse proxy with Nginx that sits on every machine, because we already have Nginx anyway to serve the web request. So it's just one more vhost. And so when we proxy, we actually proxy to localhost, and that one sends it off to the primary. And then there's this parameter in the Nginx config, which I forgot the name of, that lets you do like connection pooling. So it will open up up to X connections and just keep these open and pipe everything through that. And at first I was really confused because I got like, it was sometimes fast, sometimes slow, sometimes fast, like completely random. And what I found out, which is like interesting fact if you ever attempt this, is that like, so if you have multiple Nginx workers, like worker processes, which typically you do have like, 1 or 2 per CPU core, like it's gonna, one of them at random is gonna handle your request. And if they don't have a connection like in their pool yet, then they have to open one. So they each have a pool. It's not a shared pool. So if you're hitting it like at first, and obviously when you're trying this out, like you're reloading Nginx all the time, so every time it kills off the whole connection pool. So like you try again, it's like it has to connect to it, and the first one is slow, that made sense, but then the second one is also slow, and then the third one is fast, and it goes slow again. I was like, what the hell is going on? But once, like, I tried it with really low numbers, and eventually I found out it's like, yeah, if you put it to, like 2 workers, 2 pooled connection, the first 4 connections are super slow, and then it goes fast consistently. And so I was like, okay, now I understand. Can go back to high numbers for production. But anyway, after this, we still have a few other issues, like just network randomly failing. That's like the nature of the internet. Like if you do many requests, some are gonna fail. That's just how it is. So having the fallback there is quite convenient. Another thing that I haven't found out what it was, is that like we were going through the load balancer, like the AWS load balancer, to proxy the requests, and sometimes, like it's not very often, but it's just, again, if you do enough requests, it's gonna fail a few per day, and it's just like not good. They just time out. And the weird thing is they're processed on the server, like everything looks fine in all the logs across the whole thing, but these requests, they take like 60 seconds and then time out. So that's really not good because the user doesn't get a response for 60 seconds, and it's just like, that wasn't really acceptable. So we ended up hitting like the EC2, like the VMs directly, let's say, and bypassing the load balancer. And that's the catch with the session, the session forwarding in headers, is that header size is limited. So if your session is growing too much, eventually, like, the proxying falls apart completely, which is not good, but again, like trade-offs, right? Like for us, this works because we hardly store anything in the session. But if you're using the session as like this gigantic data store for like, I don't know, maybe like a Magento store or something, I imagine the whole cart is maybe stored in the session, or I don't know. Like some use case like that, it's probably not gonna work with this approach. So ultimately we ended up with this, where like it was really fast. I mean, now it's actually faster to hit the replica than hitting the main one. So that was really cool. But it took a while to get there. Okay. So yeah, there's still a few downsides here for sure. So if the primary region is down there, like we're in read-only mode because all the write queries are just gonna fail. Like that's just how it is. Like if you don't have a multi-master setup, that's just life. I think there's really nothing we can do about this right now. If Aurora ever like have this like multi-master setup that works reliably, I'll definitely give it a go. But right now, it's just not happening. Other downside is like the setup is quite a bit more complex than the other ones. Like we still have this Proxy SQL setup and the Nginx reverse proxy and stuff like it. It's stable because it's just like stable tech and it works well, but like to explain this to someone, it takes quite a bit more time than a more traditional setup. So yeah. So to summarize, I think it really depends on the case, on what you're trying to do. Definitely the audience is the primary factor. Is like if you only have people in a very small region, I think the only thing you get by splitting it in multiple regions is a bit more of safety in case like something really bad happens to the data center, but that's about it. So I think you have to look at your audience first. Also like responsiveness for sure. Like if in some cases it's fine to have people wait half a second for a response. Like if your business is okay with that, cool. Like I can't make that decision for anyone. And finally, like the team size. Again, like I work in very small environments, like small teams. Like we can't afford to have like 10 people managing a multi-master setup right now with like super complex rules and this and that. Like it's just we can't. Like I know it's possible. Like I've talked to many people around like at conferences and so on the last few years, and I've heard of a few people doing this like reliably with really complex setups, but usually those people were like developers and they just knew that someone was taking care of it in the company, but they actually don't know what's going on. So that shows how it's just difficult to do this at a small scale. Then the other aspect is the tech stack. So if you can, I would say like go for one of these, like maybe Google Spanner or something like that. If you go with that from the get-go, if you can foresee that you will have this problem or this need, I think it's worth like looking into it early on in the project. I think that's actually one of the main issues with this thing is that like usually people start small and they start on their little machine, and then stuff grows, and then at some point they're like, oh, like what do we do now? Like now we have a super successful startup and this and that, and like so maybe it's a good problem to have, but at that point you have to refactor everything and it takes ages, so it's not always possible. So maybe starting up earlier would be more sensible, but you also lose time, I guess, in the beginning if you do everything like more complex. So I don't know, it's a trade-off. Like you have to think about it. All right, that's it. Thank you very much. Now, if you have any questions, I think we still have 2.5 minutes.
Does the VPC peering, does that traverse the public internet across the zones, or is it going across like a dedicated tunnel?
So that I have no idea about. Like it's a really good question, and
I know like Amazon and Alibaba have a specific type of connection where they actually control the route.
right.
And it's not going across the
So I mean, I would hope that it is their own link and like that they control this very well, but
latency, but it could be much less because they
that's the thing. I mean, one thing is latency, the other one is security, right? And like the latency thing, we really cannot control this at our level, but the security stuff, that's why I'm also like, I wouldn't send unencrypted traffic on that line because I just don't know. Like, yeah. So definitely HTTPS, and like, I mean, we added some other layers on top of it just to be sure, but it's that's the problem with all these cloud providers. I think that they're very much black boxes, and they tell you we have this thing and it's amazing, and you can trust it, you can test it to some extent, but you can never really know like what's going on. Anything else? No? cool. Just one last thing, because I checked earlier, and on joined in, there was, I think, a total sum of 0 comments across the whole conference. So if I can just, as it's the last slot, I think it'd be cool if you can go check it out. Like maybe not now, because it's the end of the week, end of the day. I'm sure everyone's tired, but if you can think about it, maybe this weekend or next week. Like if you go on the joined in homepage, you should find the conference. You can then like find the talks and write some comments and ratings. I think most people appreciate it. Like I would definitely appreciate it for this one because it's the first time I give this talk. So I'm kind of curious to hear if you liked it or not. You can also come later and give me feedback in person. That's fine. But yeah, just for the others as well. Like if you can have a minute to do that, that'd be cool. All right, that's it. Thank you very much.